Okay, well, one of the most missed problems that I saw on your test was rational functions, identifying the zeros of a function. Whenever you identify the zeros of a function, what you want to focus on would be the numerator. Okay. Okay. All right, so this is your numerator right here. So that's what you want to focus on when you are looking for the zeros of a function. All right, so what you're going to do is to factor your numerator and set each one of your factors equal to 0. So here I have x cubed minus x squared minus 6x. The greatest common factor of all three of these terms would be x. All right, so that goes outside the parentheses. So then I'm left with x squared minus x minus 6. This is a factorable trinomial. All right, so I have to think about what factors of negative 6 would add up to equal to negative 1. And that would be negative 3 and negative 2. Negative 3 and positive 2, excuse me. So it would be x times x minus 3 times x plus 2. All right, now that I have the factors, I'm going to set each one of these factors equal to 0, and that gives me the zeros of the function. So here, x is just equal to 0. Here, x minus 3 equals to 0. And you solve for that, you get x equals positive 3. And the last one, you have x plus 2 equals 0. And you solve for x, you get x equals negative 2. So, my zeros of this particular function, I have 3 of them. They would be x equals 0, x equals 3, x equals negative 2. That means that this function crosses the x-axis at 0, 3, and negative 2. The next type of problem that I saw that people were having trouble with was identifying the asymptotes and the holes. So what you have to identify would be the horizontal asymptote, the vertical asymptote, as well as any holes. The first thing you want to do is to factor the numerator and the denominator as much as possible. So here in my numerator, I have 3x squared minus 12x. 3x squared minus 12x has a greatest factor, common factor of 3x. So you put that on the outside, 3x, and you're left with x minus 4. The next thing you do is you factor the numerator. The denominator is a factorable trinomial. So what factors of negative 3 add up to equal negative 2? So that would be x minus 3, x plus 1. All right, now the first thing you can tell that you're not going to have any holes because you don't have anything that cancels out. There's not a common factor in both the numerator and the denominator. So the first thing you see is that you have no holes. All right, the next thing you want to check for would be a vertical asymptote. All right, so I'm just going to call that VA. The vertical asymptote, you get that from anything that makes the denominator undefined. So you want to take the denominator and set its factors equal to 0. So here we have two factors. You have x minus 3 equals 0, and then x plus 1 equals 0. And you're going to solve both for x. Here you get x equals 3. Here you get x equals negative 1. So these will be your vertical asymptotes. The third thing would be the horizontal asymptote. With the horizontal asymptote, you want to check the degrees of both the numerator and the denominator. So the degree of the numerator is 2. And that's from, let me highlight what I'm looking at. Okay. So the degree of the numerator is, nope. I wanted to write. All right, the degree of the numerator is 2, and the degree of the denominator is also 2. Because they are equal, that means that your horizontal asymptote is a ratio of the leading coefficient of the numerator and the leading coefficient of the denominator. So that means that your horizontal asymptote will be 3 divided by 1, which is just 3. And when you write it, it's y equals 3. So here our function has no holes. It has vertical asymptotes at x equals 3, x equals -1, and it has a horizontal asymptote at y equals 3.